All right, y'all, so this is a video of me going over every single problem in this test review, so there should be no excuses when we get to the test. The first thing I want to do is I want to make a key at the top of my paper. I wrote down 3 different boxes here, and I'm going to color code each and every one of these. So the first one, I'm going to make blue. Oops, let's change the width of that. Oops. All right, so blue. Blue is going to stand for anything that has grams. All right, anything that looks for mass, grams, you need to look on the periodic table. So any problem that I come across that has the word grams in it or mass, I'm going to highlight it blue because that's going to tell me we need to look on the periodic table for the answer. Next, I'm going to do green, and green is going to stand for moles. So, moles is a middle ground. Most of the time, this is what you're given or what we need to find. And we can usually find it using what we have here, the grams from the periodic table. That would be our molar mass. Or to go to the next one, the next thing I want to highlight is pink, and I'm going to make pink stand for atoms. Anytime you see the word atoms, you need to think of Avogadro's number, 6.022 times 10 to the power 23. This is for atoms, molecules, or particles. All of that means you need to use Avogadro's number. All right, so using that key, I'm going to highlight this entire thing before we even get started. Anything that has grams in it, I'm going to go in with blue. So every single problem, for example, number 1, it says if you have 3.0 moles, keyword moles, I'm going to put in green. How many grams do you have? So we're looking for grams there. I'm going to highlight it blue. Next problem. If you have 5.24 moles in green, how many grams do you have? Blue. So I'm going to go through every single one of these before we even get started and go ahead and highlight. If you have 2.8 moles, all right, moles is green. How many atoms do you have? Keyword atoms, pink, because we need to use Avogadro's number. Same thing with the next problem. If you have 7.5 moles, how many atoms do you have? This just helps me organize this. Part 3, we need to find the molar mass. Again, anytime you see the word mass or grams, you need to look on the periodic table. So we're going to highlight that blue. So all of these, we need to find the mass on the periodic table. Part 4, using the molar mass, you're going to determine the following. So we need to find the mass of this many moles. How many moles are in 3.44 grams? So grams are mass, that's why I'm highlighting it blue. How many moles are green, are in 15.5 grams. Part 5, using the molar mass. So we're going to be using our molar mass from part 3. We need to find the percent composition. So this one is a little bit different because for the percent composition, I want you to make a little note out here. This is the percentage of each element in the compound. Y'all know what I was trying to write. So this one we're going to perform a little bit differently. And then part 6, find the formula from the percent composition. So we're going to use everything from part 5 down here on part 6. And this gives you some of the percentages, but I'll wait till the end to go over part 6. For right now, let's just focus on the first couple of problems. So everything that we highlighted here is going to go with our key. Now, Starting on number 1. By the way, all of these, we're going to be setting up tables. So if you have 3.0 moles of SB, which is antimony, how many grams do you have? I'm going to set up a table. The first thing in our table is what we're given always. So we're trying to go from moles to grams. How do we find grams? Well, our key tells us if we're looking for grams, we need to look on the periodic table at the element. So let's go ahead. I'm going to pull up the periodic table here. So that first element was SB antimony. Antimony has a weight of 121.76 grams per mole. So for every 1 mole, we get 121.76 grams. All right, remember, grams came from the periodic table. This is what we were given. Now, because I have moles on top and mole on the bottom, that'll end up canceling. So now we can just multiply straight across. 3 times 121, let's see what we get. Let me pull up my calculator. Okay. Oh my goodness. Oh, it's not done. Here we go. All right, clear everything out. Let me pull up a double screen. All right, so here we need to multiply 3.0 times 121.76. And we get a total of 365.28 grams of antimony, which is SB. Perfect, there's our answer. So on every single one of these, y'all should be showing your work and then putting your answer here. Okay? All right, next. If you have 5.24 moles of chlorine, remember, start with what you're given. Let's set up our table. And we need to look for grams. So grams, find that on the periodic table. Let me pull back up the periodic table here. So we're looking for chlorine, Cl, other side. So chlorine has a mass of 35.45 grams for every 1 mole. Now, to actually do the math on this, we're going to have to pull back up our calculator and multiply 5.24 times 35.45. Let's see what that gets us. Oops. Remind me later. 5.24 times 35.45. That gives us a total of, oops, hold on. 185.76. Remember, round to 2 decimal places. Grams of chlorine. And there's our answer. So, and I know it was grams because that's what we ended with, because moles on top, moles on the bottom cancel. We have these 2 numbers on top, multiply them, and you get your answer. Part 2, convert the following from atoms to moles, or moles to atoms. Remember, anytime you see the word atoms, let's look up at our key. Atoms, you use Avogadro's number, okay? So setting up this table, we're going to start with what we're given, 2.80 moles. And I know I can go from moles to atoms using Avogadro's number, because for every 1 mole, we get, let me zoom in here and write smaller, 6.022 times 10 to the power of 23 atoms. Sorry, y'all, I just haven't memorized. All right, this is how your table should be set up. We know I should end with atoms on top because we started off with moles. Whatever's on the top here needs to go on the bottom, so we can get these two things to cancel out. So because they cancel, I'm going to cross them. Now, we're going to end up with our answer in atoms. So let's figure out what our answer is. We're going to multiply everything on top. So let's go ahead and type it into our calculator over here. 2.80 times 6.022 times 10. Hold on. Let me figure out how to put a power on here. To the power of 23. Is it going to let me do it correctly? Is that the right answer? Or did I type it in wrong? No, that is the correct answer. Look at me go. All right, so our answer is, remember, I only want to see this first decimal rounded to 2 decimal places. So 1.69 times 10 to the power of 24 atoms. This right here, do not forget this part. This is a part of your answer. Do not leave it off. If you were to only put this, I am going to count that incorrect. So make sure you use this entire thing as your answer. Okay. Next. Now, if you look at how this is highlighted versus this is highlighted, it's highlighted the exact same way. So we're going to set up a table down here the exact same way as we did on number 3. Let's start with what we're given. If you have 7.50 moles of boron, how many atoms do you have? Again, atoms. Anytime you see the word atoms, you should think Avogadro's number. So because I have moles on top, I know I need at least 1 mole on the bottom to convert to 6.022 times 10 to the power of 23 atoms. Setting up our table this way, moles will end up canceling and our answer will be in atoms. All right, let's go ahead and type this in. 7.50 times 6.022 times 10 to the power of 23. So our answer is 4.52. 4.52, rounding to 2 decimal places, times 10 to the power of 24. So if you see that E24, that just means times 10 to the power of 24. It means the exact same thing. So don't get confused by that. That is still a part of your answer. What? Why are we erasing things? All right. So that is the first page complete. Let's go on to the second page. Part 3, finding molar mass. Now, molar mass, ding, 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 we need to look at the periodic table. We need to look up the mass of every single element on the periodic table and then add it together. So, starting with number 5, molar mass of Hg. So let me pull back up my periodic table here. All right, where is Hg? Hg is mercury. Mercury has a mass of 200.59 plus oxygen. Oxygen has a mass of 15.999. I round that to 16. And when we add these together, 200.59 plus 16, we get a total of 216.59 grams per mole. I need you to include grams per mole in your answer. This is going to help you on the problems to come. Anytime you look for molar mass, we should be ending in grams per mole. Starting with number 6, let's do the same exact thing. We're looking for molar mass. We have to go ahead and find the mass of each one of these elements, all 3 elements. So starting off with Ag. Ag, here it is. Ag is silver. Silver has a mass of 107.87 plus the mass of nitrogen. Nitrogen has a mass of 14.007, so 0.1, plus 3 times the mass of oxygen. We found the mass of oxygen right here, so I'm just going to copy that down. Just remember, because oxygen has 3, you should be multiplying this mass by 3. All right, let's pull up our calculator and see what our answer is. 107.87 plus 14.01 plus 3 times 16. No, that's not what I wanted to do. Am I going to have... Okay, my calculator is different from y'all, so let me retry that. Let's do the 3 times 16 first. Now we're going to add these other 2. Normally, you would not have to do this, but I have a different calculator on my iPad, so it's a little bit different. There we go. There's our answer. So 169.88 grams per a mole. There's our answer for number 6. Now let's do the same exact thing on number 7, except let's rewrite this without the parentheses. In order to do that, we have this 2. The 2 needs to be distributed to everything on the inside. So it needs to be distributed to O and to H. So reality, we should have 1 barium, we should have 2 oxygen, and 2 hydrogen. So using that, let's find the molar mass. All right, barium, Ba, where you at? There you are. All right, barium. Barium has a mass of 137.33. Next, we have 2 oxygen. So we're going to have to multiply the mass of oxygen by 2. And we already know what the mass of oxygen is because we've used it in the previous 2 examples. It's 16, so I'm going to copy that down here. And same for hydrogen. You have 2 hydrogen, so we need to multiply the mass of hydrogen by 2. And then if you look at your periodic table, hydrogen has a mass of 1.008. Let's round that to 1.01. Now that we have our problem set up, all 3 of these, let's plug it in. Plug it in. Oh my goodness, I canceled out my stuff. All right, 137.33. I wonder if it'll let me do it this time. Plus 2 times 16. Nope, that's not what I wanted to do. I think we're going to have to, for my calculator at least, I'm going to have to plug these in first. So 2 times 16 is 32. All right, so I'm going to rewrite this so I don't have to multiply and do multiple different operations on my calculator. And then 2 times 1.001 is 2.01. To double check myself, 2 times 1.01, 2.002, duh. Good thing we double checked ourselves, right? Now let's add these together. 137.33 plus 32 plus 2.02. That gives us a total of 171.35 grams per mole. So there are all of our molar masses on part 3 for HGO, AgNO3, and BaOH2. So here are our answers on this side. I'm going to highlight them in yellow so you can see them better. That is rough. Try again. Part 4. Using the molar mass from part 3. So all of these molar masses that we found here, we're going to use down here. So the first one is using the mass from HGO. HGO was number 5, and we found it had a molar mass of 216.59. I'm going to write that down in the top corner so I don't forget. Grams per a mole. All right, so determine the mass when we're given 1.25 moles of HGO. So again, whenever we create charts, the first thing in it is what we're given. So 1.25 moles, and we're trying to go from moles to mass, which is grams. So moles to grams. And we can do that using our molar mass. Moles to grams. So for every 1 mole of HGO, we get 216.59 grams. Here, moles will end up canceling from the top and the bottom because it's the same. And we can go ahead and multiply what we have on top together. All right, we have 1.25 times 216.59. And we get this really long number. This long number, let's round it to 2 decimal places. 270.74 grams. There's our answer. Now for the next one, it's asking us how many moles are in this many grams. So again, it's asking us for grams. We have to use the molar mass from part 3 on this problem. The molar mass from part 3 for AgNO3 was 169.88. Grams per mole. Now be careful. Some of you may want to set up your table exactly like this one, but we cannot do that because this problem, they gave us moles. On number 9, they are giving us grams. So our table is going to be a little bit different. We always start off with what we're given, 3.44 grams. If I have grams on the top, grams has to go on the bottom to convert into moles on top because that's what we're looking for, how many moles. Now, where are we going to find grams for every mole? Up here, this number, our molar mass, converts 169.88 grams for every 1 mole. When we do this, grams will end up canceling, but the numbers themselves are on the top and the bottom. 3.44 divided by 169.88. So, clearing out my calculator, 3.44 divided by 169.88 will give us a total of 0.02 moles. That's a very small number, but hey, that's our answer there. And there is your answer for number 9. So this one we ended up in grams, this one we ended up in moles. Let's see what it's asking us to find on number 10. How many moles are in 15.50 grams? So this one's going to be set up like number 9. Very first part, using your molar mass from part 3. So for BaOH2 had a molar mass of 171.35 grams per mole. All right, let's set up our table. First thing in our table is what we're given in the problem. We're given 15.5 grams. And we have to go from grams to moles. So, using our molar mass, going from grams to moles, 171.35 grams for every 1 mole. Now, grams will end up canceling on top and bottom. Now we have this number on top, number on the bottom, and we need to divide because they are separated. So we have, clear out my calculator, 15.50 divided by 171.35. And you get this really long number, but we just need to round it to 2 decimal places. 0.09 moles. And there's our answer. All right, so here is how you do part 4, converting from grams to moles or moles to grams. Quick water break. Okay, so now we are on part 5. Part 5, we have to find using the molar mass, we have to find the percent composition. So basically, that is what percentage does each element make up in this compound. If you look at number 11, you have 2 elements here, Hg and O. And we can use our molar mass from part 3. So if I go up for part 3, HgO had a molar mass of 216.59. So that would be your molar mass is the total mass. I'm going to put on here total mass of this entire compound. Now I forgot the number. It was 216.59. grams per mole. Now, how do we figure out the percentage of each element? Well, you're going to have to set up 2 different things on your paper. I'm going to start off with Hg on this side and O on this side. Starting off with Hg, you want to take the part and divide it by the total. So the part of Hg is the mass. What is the mass of Hg? And we know what our total is because we found it using the molar mass, 216.59. I'm going to go ahead and write that on the bottom since we already have it. So what is the mass of Hg? Well, if you go back and look at part 3, we have Hg and O. This was Hg, this was O. So Hg has a mass of 200.59. So that is the part, 200.59 divided by the total, 216.59. Now, if you were to plug this into your calculator, you're going to get a decimal. So let's go ahead and plug it in. See what we get here. 200.59 divided by 216.59. 0.9261. And if you were to change this into a percentage, because we are looking for percent composition, you would only have to move your decimal over twice in order to get a percentage. So this makes up a total of 92.61% of this entire compound. So Hg takes up a majority of the compound. Now let's go ahead and do the same exact method, but for oxygen. So again, you always take your part and you divide it by the total. Part over total. All right, the part or the mass of oxygen, if you don't have it memorized, it's 16. If you didn't have it memorized, you could have looked it up on the periodic table. The total is our molar mass from up top was 216.59. Now, when you plug this part into your calculator, again, we're going to get a really long decimal. So clear it out, 16 divided by 216.59, 0.0739. And we have to move our decimal over twice, 1, 2. So it takes up a total of 7.39%. So our final answer are both of these actually. So Hg makes up 92.61% and oxygen makes up only 7.39%. I would prefer if you did write these answers over here on the side. That just makes it easier to distinguish your work that you've done from your actual answers. I understand up here, I didn't do that, but I did highlight them on the end. So just in case, you can do it. I would just prefer if you wrote your answer in the answer box. Your test will be set up in this exact format. All right, doing the exact same thing on number 12. We need to go ahead and look up the molar mass for number 12, AgNO3. So the molar mass here is this. I'm just going to copy and paste. I understand y'all cannot do that, but it's easiest for me to do that. You can copy it down on your paper, how I have it on mine. I'm going to resize it so it's smaller. All right. So I just stole this straight from part 3. This is the molar mass of this compound, AgNO3. So if I were to label each part, I have Ag here, I have N, and I have O. So then I have our total. I can use this to help me find the mass of each of these elements. So starting first with Ag, remember, you want to do your part divided by the total. So the part of Ag is 107.87. Divided by the total, 169.88. So typing this in, 107.87 divided by 169.88. we get 0.6349. We'll leave it there. So this is about 63.49% once you move your decimal over twice. So that's just for AG. Now we have to do the same for N and also O. So doing for N, nitrogen. Yeah, let's do a different color. It's probably easier for y'all to see it. So nitrogen has a mass of 14.01. And we're going to divide it by the total, 169.88. So clearing this out, 14.01 divided by 169.88, we get it 0.0825. And if you move your decimal over twice, you get 8.25%. And that's for nitrogen N. Last part, let's do the same with oxygen. Let's do this pretty color, orange. All right, so oxygen, be careful here. Oxygen has 3. So we need to make sure that we multiply the mass of oxygen by 3. So I'm just going to take this part. 3 times 16, 3 times the mass of oxygen. Put that on top. And then divide it by the total, which is 169. What is going on? Oh my God, no. How did that happen? Oh, that was the ad for the calculator. Embarrassing. All right, plugging this in. We have 3 times 16 first. Divided by 169.88. I'm going to write this below it. So 0.2826, which is 28.26%. Now combining all of my answers over here on the side, I'm going to write them all. So AG was 63.49%. Nitrogen was a total of 8.25%. And oxygen had a total of 28.26%. Look at us go. Woo! All right, last one. Again, I am using all of the information, the molar mass from part 3. So just like I did on the last one, I'm going to still this. Let's just still this part. So this one had a molar mass. Let me paste it. Let's erase that. And let's make it smaller so it fits. All right, so I'm going to label this one as well. Let's do, the first part was BA. This is BA's mass. The second part is oxygen, and the third part is hydrogen. Starting off with BA, barium. The part, 137.33, divided by the total. The total was our total molar mass of 171.35. Divide it. Pull up your calculator. Don't pull up another dumb ad. So 137.33 divided by 171.35. And we get 0.8015. 0.5, which is about 80.15%. All right, so there's barium. Let's go ahead and do oxygen next. Oxygen has a mass of 32. Don't forget, yes, there are 2 oxygens here, right? But oxygen's mass is 16. Multiply that by 2, you get 32. We're going to divide that by the total, which is 171.35. So typing this in, 32 divided by 171.35, 0.1868, which is roughly 18.68%. And doing the last part for hydrogen, hydrogen had a mass of 2.02 divided by the total. I'm going to hurry up and plug this in because there are people coming to class. .0118, which is about 1.18%. And there are the answers for all 3 of these: barium, oxygen, hydrogen. That's it. Okay, on part 6, we're going to be finding the empirical formula, which is basically what is the formula that looks like this. We have 3 different elements on number 14. You have potassium, sulfur, and oxygen. And it gives you the percentages of each one. So first thing I need to do is set up a chart for all 3 of these: potassium, sulfur, and oxygen. And in this chart, I am going to take what we're given, these percentages. Blake, not have video recordings to show to your mom. I'm going to take the percentages and turn it into grams. So 40%, I'm going to change that to 40 grams. 20% of sulfur will be changed to 20 grams of sulfur. 40% oxygen, 40 grams of oxygen. And I need to change these from grams to moles to determine how many we have of each compound, of each element in the compound. So in order to find grams to moles, I have to look at the periodic table for the weight. So for potassium K has a weight of 39.098 grams for every 1 mole. So 39.1 grams for every 1 mole, if we were to round that. Next, I'm looking for sulfur. Sulfur has 32.07 grams for every 1 mole. And oxygen is 16 grams for every 1 mole. Now, on every single one of these, we have to go ahead and divide the top number by the bottom. So plugging those in. Hey y'all, I'm still videoing, so y'all be quiet. 40 divided by 39.1, 1.02 moles of K, or potassium. Next we have 20 divided by 32.07, which is 0.62 moles of sulfur. Then we have 40 divided by 16, which is 2.5 moles of oxygen. Now, looking at these three, which one of these three is the least amount? Well, sulfur has the least of 0.62. So I'm going to divide every single one of these by 0.62. Y'all, I'm videoing. I know for sure that this middle one, sulfur, same number on top and bottom, is going to give me 1 mole of S. This top one, let's plug it in. 1.02 divided by 0.62 gives us 1.6. Now we want to round to the nearest whole number, so this would actually round up to 2 moles of K, potassium. And then the last one, oxygen, 2.5 divided by 0.62 gives us 4.03, so 4 moles of oxygen. And if you were to put this together, that means we should have 2 Ks. Y'all, take a seat and shut your mouth. We should have 2 potassiums, 1 sulfur, and 4 oxygen. So this is the formula, K2SO4. And obviously, you know, I'm in a very wild classroom right now, so this is okay. So this very last problem, this problem, we have 2 different elements here. We have 52% of calcium and we have 48% of carbon. So just like the first one, we have to set up a table for calcium and a table for carbon. We're going to take that percentage and we're going to turn it into the number of grams. So calcium has 52 grams and carbon is going to have 48 grams. Now we have to turn these from grams to moles. Grams to moles using the weight off of the periodic table. So pulling up our periodic table, Ca calcium is going to have a weight of 40.08 grams. Let me write that better. For every 1 mole. Carbon is going to have, oh, that's oxygen. Carbon is going to have a weight of 12.01 grams for every 1 mole. Now, to do the math on this, take the number on top, divide it by the number on the bottom. So 52 divided by 40.08, we get 1.29 moles of calcium. Same thing for the bottom. We're going to do 48 divided by 12.01. Hey, Miley, take a seat, please. Y'all, stop talking. Which is 3.99 moles of carbon. Now, choosing which one is the least. Here, calcium is the lower of the two, the least amount of the two. So we're going to divide both of these by 1.29. 1.29 divided by itself would give us 1 mole of calcium. 3.99 divided by 3.99 divided by 1.29 gives us about 3. We're going to round it to the nearest whole number of carbon. So when we put it together, we should have a final answer of CaC3. That's your answer.